What if the entire AI industry has been chasing the wrong thing? For years now, the race has been all about building bigger and bigger and bigger models. But what if the real secret to smarter AI isn't about size at all? What if it's about teaching them how to think? Right now, the AI landscape is basically an arms race for size. I mean, companies are pouring billions of dollars into more data, more GPUs, and models with a truly staggering number of parameters. We're talking trillions. The whole mantra has been super simple: bigger equals smarter.
But what if that's not the full picture? What if the key isn't a bigger digital brain, but one that can just think longer and harder about a single problem? Well, that's exactly the question a 22-year-old developer named Kai Gomez decided to dive into, and his work might have just started to unravel one of the industry's biggest secrets.
So, at the very center of this whole mystery is a rumored AI architecture from the company Anthropic. It's something that's just been whispered about in developer circles. They call it Claude Mythos. And this is the story of one person's attempt to figure out what makes it tick. See, Anthropic, the company that makes the Claude models, has kept Mythos completely under lock and key. There's no official paper on it, no technical breakdown, nothing. It's just whispers and speculation. It's this total enigma that is the entire AI community trying to peek behind the curtain. So Kai Gomez took all those little clues, all those fragments, and built something called Open Mythos. Now, it's really important to get this. This is not a leaked clone. It's an open source, testable hypothesis of how Mythos might work. And it's all built around a pretty radical idea for how to design an AI. And that gets us to the really cool part, the core technical idea. This isn't just about making models smaller for the sake of it. It's about making them way smarter by completely rethinking how they're even built from the ground up. Okay, so think of it like this. The two approaches are totally different. Standard models, like the GPT family, they get smarter by just stacking more and more layers on top of each other. It's like building a taller skyscraper. But this recurrent approach that Open Mythos explores, it uses a much smaller set of layers and just loops through them over and over again. So instead of a deeper model, you get deeper thinking. This architecture is called a recurrent depth transformer, or RDT for short, and it has this beautifully simple three-part structure. First, you've got the prelude, which just encodes the input one time. Then comes the recurrent block. This is the heart of the whole system. It loops maybe up to 16 times, refining its internal understanding with every single pass. And that iterative process is what allows for that deeper thinking. And then finally, the coda spits out the final answer after all the thinking is done. So you might be thinking, wait, isn't looping through the same thing 16 times just a waste of effort? Well, the genius here is how it avoids that problem. On each loop, the model actually re-injects the original question to keep it on track. Plus, it uses what's called a mixture of experts system, which means it activates different specialized neurons on each pass. So every single loop is a new chance to look at the problem from a totally fresh angle. All right, so how does this new approach actually perform in the real world? This is where all that theory meets reality. And honestly, the results are shockingly efficient. To test this whole thing out, researchers built a model using this RDT architecture with just 770 million parameters. Now, in a world where models are regularly measured in the billions or even trillions of parameters, yeah, this is a pretty small model. And here is the big payoff. That little 770 million parameter model performed just as well as a standard transformer model with 1.3 times billion parameters. That's nearly double the size. It proves you can get the exact same quality with a much, much more efficient architecture. And this is the crucial point. It actually changes how the AI reasons. We're all used to chain of thought, right? Where the AI visibly writes out all of its steps for you to see. Well, the RDT does all of its reasoning internally in what's called latent space. It is literally the difference between doing math out on a piece of paper versus solving it entirely in your head and then just giving the final answer. And this hidden reasoning unlocks some incredible new abilities. It's way better at what's called systematic generalization, which just means it can combine facts in new ways it was never explicitly trained on. It's also capable of depth extrapolation, which means it can solve problems that are more complex than anything in its training data just by looping a few more times. It really suggests the bottleneck might not be what the AI knows, but how well it can think. Okay, so this isn't just some cool research project anymore. we're actually starting to see these core principles, efficiency, deeper thinking, modular experts popping up in some of the most advanced commercial models out there right now.
For example, take a look at Moonshot AI's new model, Kimi K2.6. On one of the absolute toughest benchmarks, a set of doctorate-level questions, it actually manages to slightly edge out both Claude Opus and GPT 5.4. Now look, these are company-reported numbers, so we should take them with a little grain of salt, but the trend is definitely there. Smaller, more efficient models are competing at the very highest level.
And when you pop the hood on Kimi, you see the exact same principles at play. Even though it's a massive 1 trillion parameters, it's built from the ground up for efficiency. It uses that same mixture of expert system, and it can even spawn hundreds of parallel AI agents to go tackle complex problems. It's a beast, for sure, but it's a smart one that thinks efficiently. And we're seeing a similar story from xAI with their new Grok speech-to-text API. Their model is showing a way lower error rate than major competitors when it comes to transcribing phone calls. So whether it's language or voice, the industry is really starting to shift its focus towards smarter, more efficient performance.
All of this brings us right back to that big question we started with. As we move forward, is the ultimate goal just to build bigger and bigger digital brains? Or is the real frontier teaching them to use the brains they already have more effectively, to think longer, deeper, and harder? The answer to that could define the entire next decade of artificial intelligence.